Okay, so today we're going to try to solve LeetCode problem 983, minimum cost for tickets. In a country popular for train travel, you have planned some train traveling 1 year in advance. The days of the year that you will travel is given as array days. Each day is an integer from 1 to 365. Train tickets are sold in three different ways. The first way is a one-day pass is sold for cost $0. Okay. And a 7-day pass is sold for cost 1, and a 30-day pass is sold for cost 2. The passes allow that many days of consecutive travel. For example, if you get a 7-day pass on day 2, then you can travel for 7 days, day 2, 3, 4, 5, 6, 7, and 8. Right, covers 7 days. So we are asked to return the minimum number of dollars you need to travel every day in the given list of days. Okay, so in the first example, we're going to travel on day 1, day 4, 6, 7, 8, and 20. Right, and the tickets are sold in 3 ways. The 1-day pass is $2, and the 7-day pass is sold for $7, and the 30-day pass is sold for $15. And the output is 11. So how it is calculated? Let's take a look. Okay, so the cost is 2, 7, and 15. So if we buy a daily pass, right? So every day we're gonna pay, 2 days, $2 a day. If we buy the 7-day pass, so every day it's gonna be $1. And if we buy the monthly pass, and every day we're gonna pay 50 cents, right? Half the dollar. So as we can see, the longer the tickets covers, the less expensive we're gonna pay for each day. Yeah, that makes sense. Okay, so now in the example number 1, we're gonna travel on day 1, 4, 6, 7, 8, and 20. Right? So one way we can buy the tickets is we buy the daily tickets every time, right? So we're gonna travel 6 days a year, right? And if we buy daily tickets every time, it's gonna be $12. Right, and the output is 11. So that basically means there is a way that can help us save $1. Okay, let's see how we're gonna buy the tickets to save some money. Okay, on day 1, we buy the daily tickets, okay, which is $2. And on day 3, you bought a 7-day pass, which covers day 3 to day 9. Okay, so in this example, it covers day 6, 4, 6, 7, and 8. So we pay $7. And then we buy another 1-day pass for the 20th day. So that's gonna be $2. So if we sum them up, it will be $11. Okay, so the idea I think is, if those days you want to travel are very close to each other, right? You're gonna buy a pass that gonna cover multiple days. That's kind of the idea, right? Okay, now how can we design an algorithm to help us to pay the minimal number of dollars, but we can still have enough tickets to travel in the days that we defined? There are some notes here. Okay, a year has at the most 365 days. Okay, and okay, and days in strictly increasing order. Okay, this is a very important information. So the days is sorted in the input array. So it's going to be 1, 4, 6, 7, 8, 20. You won't have like 1, 6, 7, 4, 28. So the days are defined in ascending order. And cost is always 3. So it only gives you 3 ways to buy the tickets. And the cost of the tickets is between 1 and 1,000. Okay. I think this is a DP problem, right? Dynamic programming. So the idea of dynamic programming is we divide a big problem into smaller and easier sub-problem, right? And then we try to find the optimal solution for our sub-problems. And we also use some memorization technique to help us save our calculations. So eventually we kind of use divide and conquer idea to use those sub-problem optimal solution to get our optimal solution for the entire final solution, right? So now what is our sub-problem? I think our sub-problem is, let's use this example to demonstrate. So I think the sub-problem can be defined as, like say we are at a certain day, I, right? We can define a sub-problem that is, what is the minimum number of dollars we need to pay from day 1 to day I, right? What's the minimum number of dollars we need to pay in order to travel from day 1 to the current day? Right. If we have that minimal amount of dollar at I, then what is our state transition equation? That means how we calculate the minimum amount of money for the next travel day, which is I plus 1. So in I plus 1, we have 3 options to buy the tickets. One is cost 1, cost 0, right? In that case, we're gonna say we need to plus the minimal amount of money we need to pay on the previous day, right? If we buy the 7-day pass, right? If we buy the 7-day pass, say we add I, and then it's gonna cover 7 days including day I. So this one gonna be I minus 6. So this gonna be 7 days. So the total cost will be cost 1 plus our minimal cost at day I minus 7, right? Yeah. And similarly, if we buy the 30-day ticket, we need to plus the minimal amount of money is to pay at I minus 30. Right? This is going to be our state transition equation. But we need to think about, it's possible that this number, like I minus 7 or I minus 30, my I minus 1 could be a negative, right? It could be a negative. If that's the case, we need to, if that's the case, how are we gonna do? Yeah, this part is gonna be 0, right? Let's say I is 6, right? Then I minus 7 is a negative 1. So if we buy the 7-day pass, it will cover all the days before day 6. So we just need to buy that one ticket. Okay. So this is the days that we need to travel. And okay. I think let's try to code it. First thing first, let's do some input check. If this is null or have length as 0, we don't need to travel, so we don't need to pay tickets. Right, now we need a DP array. So DP, so how many days we can have in a year? 365. So we need to define array that is that has 366 elements, right? Because index starting from 0. And our days actually is starting from 1, so our base will be dp 0 equals 0. We don't need to travel on day 0 because such a day doesn't exist, right? What is DPI? DPI is the minimal number of dollars we need to pay from day 1 to day I, right? And one thing that I realized that we know those days we need to travel, so we do this calculation for those days we need to travel. But for those days we don't need to travel, for example, day 5, if we don't need to travel, the minimum cost, how we calculate the minimum cost for on that particular day, day 5. Let's say on day 4, the minimum cost is, let's say, $8. We don't need to travel on day 5, right? So day 5, the minimum cost will be the same as the previous day, which is $8. So I think we need somehow to check whether we need to travel on particular day. We can use the hash set to help us achieve the O1 search time, right? Okay, now we just need to calculate the minimum number of costs for every day, starting from day 1. Okay, so if we don't need to travel, okay, then the DPI will be the same as DPI minus 1, right? Then if we need to travel, what we need to do is we have 3 options to buy the ticket. Option number 1, we buy the 1-day pass, which is cost 0. And then we add the minimum number of money we paid on the previous day, right? And another way we buy the tickets is to buy the 7-day pass. If that's the case, we need to add the minimum number of money we paid 7 days ago, right? But we need to think about that corner case I mentioned about. We need to compare with 0, right? If it's 0, we just use 0. If it's less than 0, we're going to use 0. So this is going to be a max.max function. And similarly, this is the cost, minimum cost if we buy the 30-day tickets. Alright, so eventually we just need to update our DP array, right? Fill in our DP array. That's gonna be the minimum value between C1, C2, and the C3. Okay, so eventually we need to return the last day that we need to travel. Right? So let's compile the code. Okay, good. And let's try another test case. Okay, let's submit it. Okay, accepted. And what's the time complexity of this solution? We have a DP array, which is array has 366 numbers. Do we really need to assign 366 memory cells here? We don't, right? Let's do the enhancement later. What's the time complexity of the current implementation? So this, we define the DP array and then hash map. So these actually are all one space complexity because the days are fixed. And then we just need to do a traverse, right? The traverse, the iteration only takes, yeah, at most 365, right? So it is a O1 solution. Interesting. Yeah, it's a O1 solution, but the and the time complexity is O1 as well. Okay. And now I realize that we probably don't need to assign 366 memory cells here, right? Actually, we just need to know what days we need to travel, right? We probably won't travel every day during the year. Okay, so last travel day. Then we just need to create an array that covers the last day, right? Why we add one here? Let's say we travel at day 1, 4, 6, 7, 8, 20, right? And our last day is day 20. If we create an array that has 20 elements, the index of the last element is going to be 19, right? So in order to use our index to represent our day, we need to add one here. So that's the reason. Okay, so here we need to dp, right? Yep. And this is gonna be our last day. It doesn't have a lot. Time complexity and space complexity will be the same. Just we don't need to assign like 366 to the array, right? Let's compile. Okay, submit. Yeah, as you can see, time complexity, runtime, the same. It's interesting. So the memory usage here actually is larger. Anyway, so I know LeetCode is not always accurate, but yeah, so we can use the DP idea to solve this problem. This is a very interesting problem, good problem. You can see a lot of people has voted for this one. Yep. Okay, that's it.